Lesson 64, angles interior to circles. So a segment or arc is said to subtend an angle if the endpoints of the segment or arc lie on the sides of the angle. So if you have a segment, if you have an angle that goes through the endpoints of the segment, so the endpoints of the segment is on the angle, then you can say that this segment subtends the angle. And then if you had like a circle and an angle in the circle, any angle, so this is an arc whose endpoints are on the angle. So you can say this arc subtends the angle. So that's just some vocabulary word right there. So we have a theorem about arc subtending angles. That was beautiful. Okay, so let's.
I do know.
Thank you. And this is B, and we're going to put an E over here, and we're going to put a tangent line through B, and this has an A, and this has a D. Okay. Oh, we have to connect BC, sorry. So here's the theorem. It says that the measure of angle ABC is equal to half the measure of arc BEC. And the measure of angle DBC is equal to half the measure of arc BC. So it's the same thing as inscribed angles, only one of the sides of the angle is going outside of the figures all. So the endpoint, let's see, one side of the angle is part of your tangent line. But so it's the same thing, it's just equal to half the arc. So if we have a circle O, and we have a Q right here, an R right here, and a P right here, and this arc is 100 degrees, and PQ is a tangent, then we can say the angle, the measure of angle RQP will be 50 degrees because it's equal to half the measure of the arc. And then one more example, circle C, this is E, F, tangent at E, this is D, this arc is 110 degrees. Okay, find measure angle D, E, F. Oops, I'm going to put a G over here so we can talk about it. So the measure of arc DGE, say again. The measure of arc DGE is equal to 360 degrees minus the 110. So you get 250 degrees. So the measure of angle DEF is half of that, which equals 125 degrees. And we have one more theorem with an example. Okay, so draw your circle. This time, we're going to draw two segments that form an X in the circle. We'll call this A, B, C, 2. No, it's a D. Funny. We'll call this angle 1 and this angle 2. I didn't mean to make it look like they were perpendicular, but here's a theorem. The measure of angle 1 equals 1/2 the measure of arc BC plus the measure of arc AD. So if you see the measure of angle 1 right here, the arc that subtends it, BC, and the arc across from it, AD, if you add those together and take half, that will be the measure of this.
Oh, yeah.
Okay? And the measure of angle 2 equals 1/2 the measure of arc AB plus the measure of arc DC. So we're going to do an example. So we have a circle, start at 2 o'clock, it draws much better. We have A, B. This is angle 1, that's angle 2, this is 70 degrees, and that's 195 degrees. So if I wanted to find the measure of these two angles, measure angle 2 equals 1/2 of 70 plus 195. So when you add those together, you get 265 divided by 2, which equals 132.5 degrees. So then the measure of angle 1 equals, so you can do,
Or would you do 180 subtract 132.5?
oh yeah, 180, because this makes a straight line. You could do that. Or we could do half of these two added together, and that would just be 360 minus 265. So I do too. I think it's a great idea. But we're going to write down anyway. Or 360 minus 265 divided by 2. Okay, end of lesson.